You guys ready?
Maybe.
All right. Here we go.
But hitting before naturally.
6-2.
People are still getting 3 points.
Like I said, when you make your note card, title the section with this phrase here, because when each question comes up and they're all mixed together, you'll know which section to go back to. So we are still doing confidence intervals. Still for the population mean, with here's where the change comes in, small sample. What did it say in 6-1? Large sample. What was the magic number for large? 30. So small sample is going to be under 30. Okay, so special things have to happen. The first thing, just remember that central limit theorem, if we're going to have a number in our sample that's under 30, we have to know that the population was normally distributed. So they've got to tell you. So key, the population must be normally distributed. So that somewhere in the problem, it's got to say, it is known that the population of backpack weights are normally distributed. Because if you've got a small sample and it doesn't say that it's normally distributed, you cannot do any stats with it. It's impossible. Okay? The second change from the first section is that our formula used z-scores in it to calculate max error. Big E was the z-score for a confidence level. Now those scores are going to change to t-scores, which is the reason I passed out the t-table. So the critical values they call them, I don't know why they call them critical values, are based on the t-table, not z-scores. And then the third change is that where z-scores were based on the level of confidence, we looked up the different z-scores for 90%, 95%, 99%. So with z-scores, we need to know our level of confidence. For t-scores, we need to know level of confidence and what's called degrees of freedom. So t-values, t-score, t-value, same thing. T-values are based on degrees of freedom. And our DF, degrees of freedom, are always your sample size minus 1. So 1 smaller than your sample size. So those are the changes. So before we actually do a confidence interval, we're going to learn how to read the t-table. So our first example is reading the t-table. Find the critical t-value for normal populations with, let's say, sample size, we'll do 2 of them. A sample size 25 and a 90% confidence level. So we know it's normally distributed. We're doing 90%, and we want the t-values. This is what we're looking for here. Okay. So grab your t-table. You're on the t side, not, this is chi-square, this is the chi-square, we'll do that next week. So make sure you're on the t side. If you look, here's the df right here. This column, 1, gosh. Okay, df. How many df degrees of freedom for this problem?
24.
24 df. 1 less than the sample size. So df is 24. So you're going to go down to the 24. And then if you look at the bottom, we've got our common levels of confidence. So 24 and what did I say, 90? 90, so where do those intersect? 1.711.
Wait, what? 24, where'd you use the 90? Like, I know the 90's on there, but I mean, like, where
Confidence levels down here on the bottom.
Oh. Oh.
Are we good? Everybody read their table?
You get like 85.
They won't do that. Otherwise, well, maybe it's just average, but I don't think we're going to do anything that's not on here.
Alright.
Okay. Otherwise, I would say it's an averaging thing.
Well, that's just your answer.
Yeah, what was that again? 1.711. And negative 1.711. But again, our formula is going to always take the positive one when we get to it. Practice one more. Just have to read the table, because that's the first, well, that's part of it. Let's say we had a sample size of 15. Confidence, let's go 95% confidence level. Read your t-table. What are you guys getting?
2.145.
I also got 2.145. Any questions on where 2.145 came from? Okay. So now your steps. We had a 3-step process for creating a confidence interval for population mean. We have a 3-step process again. So the small sample confidence interval steps.
How long do you think
It's 3 steps. It's about 4 lines on your paper, maybe 5 lines. 6 lines, I'd say. 1, 2, 3, about 5 or 6 lines. Okay, so first step, just like for doing large samples, you have to find the sample mean and the sample standard deviation, if it's not given. So they may give them to you directly, or you if they give you the data, you got to run 1-var stats and get those.
Okay, was S your, standard deviation?
Of the sample, yes.
I was trying to figure that out.
Yep. Okay, then you calculate.
Is this something we're gonna wanna put on your check card too?
Yep. Yeah. Definitely put this right after that beginning stuff. Calculate the max error. How did that formula work with the large sample? Do you remember how the max error formula went? It was z-score times standard deviation of sample size. The only thing that's going to change is instead of z-score, you use your t for your confidence level. The little c stands for your confidence level. Multiply by the population standard deviation if they give it to you. If it's not known, what goes there? S. Divide by square root of sample size. So, use S if sigma is not known. Is not given, I should say. Either way. Same 3 steps. So what's going to be the challenge when the test comes along? gonna say, find the, confidence interval for population mean. You've gotta know, you've got two sections on your note card that have population mean, large sample, small sample. That's the only thing that's gonna make the test challenging, is you knowing the difference, that there were two formulas, or two ways to do it, depending on if you had a large or small sample. So third step is to write the interval. And the population mean is going to be the sample mean plus and minus the max error that you calculated in step 2. Same thing, just different, exactly. Good way to put it. So let's try one example here. So we are going to randomly select 16 restaurants and you are going to be in charge of measuring the temperature of their coffee that they serve. Measure the coffee temp. And you find that the average temp was equal to 162 degrees Fahrenheit. With standard deviation, 10 degrees. Find the 90% confidence interval for the mean temperature of restaurant coffee. Assume
No.
coffee temps are normal. Distributed. Normally distributed.
Well, how many is this gonna take? Do they have?
Not much. It's a short process. Okay, so first of all, the confidence interval is for the mean. On Monday, that's going to say find the, I think it's a proportion. So you're always going to want to read the question. Which interval am I finding? Is it for a mean? Now that it's about a mean, is it a large sample or small sample? Small. If it's small, we got to make sure we can do it. Can we do it? Yes. It's right here. So all of that happens. And now we go. So what did this small sample with a normal population tell us we're doing? Which one? Z or T? T. So we're doing a T one. So we're going to go through all three steps. Do I know the sample mean? What? Yeah.
Okay, so since it says 16 restaurants, it's small because it's less than 30, right?
Yes, for now.
Okay, and then, okay, I don't want to say too much.
Okay, don't think, because I'm going to throw a little curveball at you after this. There's a small curveball coming. But, okay, from our 16, you measured them, you averaged them, you got a 162. Yes?
Why did you ask if we could do it?
Because if it's a small sample and it did not come from a given normal distribution, you can't do it.
Oh, okay.
You don't have that, that goes back to that central limit theorem. Because it's only normal if it comes from a normal population with a small number. Okay, this standard deviation, is that S or is that sigma? It does make a difference that you know that.
Standard deviation is a sigma.
No, because it's probably only for 16 restaurants.
Is this referring to the sample of 16 or is this referring to the entire population of all coffee temperatures from restaurants?
Sample.
It is referring back to the sample. This is an F. Okay, first step's done. Second step. calculate big E. Formula says I need the T value for this problem.
1.753.
That is not what I have written down. But you could be right.
1.753.
Oh gosh, do I have that wrong in here?
Wait, what is?
It's 15.
15,
15 over
90%. Oh, I wrote 95 on my paper, that's why. I don't have the same thing here. That was wrong. Okay, so what do you guys have? 1.753? Are we in agreement? Yeah. Okay. That is why we are different. Multiplied by 16? Or 10. Where did I put 16 down? It says 10. Oh, I put the sample size, for God's sake. 10. 10. My bad. 10.
No, it looks like a number.
Yeah. Well, somebody could have told me I put the sample size there instead of the standard
Well, that's
deviation.
right. But then you put the arrow and we're like, oh, well.
Well, because it's referring back to that.
Yeah, we're like, no.
Did you say something, Holly, and I ignored you?
No, I just
Oh.
wasn't watching you. I
Oh.
was writing it down.
Oh. So you wrote the right thing down?
Yeah.
Yeah.
Happy birthday. That's what winners win.
Okay, what does this calculate out to?
12.
12? Well, I don't have the right thing.
We don't personally.
2 decimal places will be good, even though they were going 3 on the book. 12.38? 4.38.
Yep.
Oh, I should have turned it off.
Okay, and now you're ready to write the interval that you're 95% confident you expect all restaurant coffee temperatures to fall in between. So you take the sample mean of 162, then you add and subtract that max error that we just found. Oh. So the upper end is going to be 166.38. Can't subtract very well in my head.
157.62.
There we go. So, if this curveball wasn't coming your way, life would be good. Okay, now there's a curveball coming.
Wait.
There is a curveball coming your way.
Am I just gonna what I kind of was
Here we go.
Over there and it curved and hit me.
Yes, it might. Okay, we're going to do a little flow chart. Should you be using Z or T? That is the question. Okay, first thing you ask yourself is sample size greater than or equal to 30. If you answer yes, I see it's greater than or equal to 30, should you be using Z or T? Z. Done. Don't even have to look at the rest of this flow chart. If you answer no, it's not greater than or equal to 30. Now you've got to ask yourself, is the population given as normal? Is population given as normal? And by that I mean, is it normally distributed? I just don't like writing all of it out. If you answer no to that, it's not given to me that it's normally distributed, what happens? Not possible. Neither. Can't be done. What do we put there?
Can't do.
Not possible. Can't do. If you answer yes, it's given as normal, now you got to ask yourself, which standard deviation is known? find one to show you just in case, because it will come up. Oh, no, chapter 6. 1 second. Okay. If the sample standard deviation is given, you're going to use the T, like we just got done doing. A small sample from a normal population, we used our sample of 16, the standard deviation. Sometimes they will give you the population standard deviation. If they have a small sample, listen, guys, small sample with the population standard deviation given to you, you are still going to use a Z there, and that's the curveball. So it's a small sample, but you're still going to do a Z because they give you a population value.
Whoa.
Okay?
That's the football.
There's the curveball. And I'll show you how they would do that to you. Number 11. In a random sample of 5 microwave ovens, the mean repair cost was $75 and the standard deviation was $12.50. This $12.50 is referring back to this sample of 5, agree? So that would make this an F. So that's a small sample and they tell you it's all normally, so that would be a T problem. But now on 13, suppose you did some research on the repair cost of microwave ovens and found that the standard deviation, sigma, was $15. Now you're going to use Z, and when you calculate big E, you're going to use the 15.
Question, is it always going to tell you that?
Yes. You have to be able to distinguish that this was referring to the sample, and then they'll give you this,
So
that this is the
You
population.
always know when it's a sample.
You just gotta, yeah,
Because it won't tell you.
right.
Alright.
Okay, so that's the curveball. That's the curveball.
Testing, too, will be like that?
Yes.
Okay.
All right,
Then that's not bad.
so your assignment then. Oh, the very end of these problems, I'm gonna, this last chunk, you do not, when I write it down, you do not have to calculate the intervals. All I want to know is whether you would do Z or T with the given information.
Okay.
So that's the end of the assignment. So we're going to ignore directions at 21. Just tell me whether it should be Z or T. Okay, so you've got page something. Find my white book here somewhere.
I don't know what it is.
Where is it?
I want to make ice cream.
Oh, Jeremy.
Oh, here.
Like it was at,
For what?
it was like.
I know.
Before we started again, and you could easily hear it.
2.
Everyone was like looking at
Oh my god. I was talking to some girl on Twitter. I don't remember what her name was. She was like Marquette, I think. And she had a skin tweet on her Twitter. And it's her riding this little tiny pedicure, and all of a sudden she wipes out and smacks her face like it looks like she's beyond line. I have to find it. She's like, how old is your head? I will find it.
Okay, so 12 through 20 is follow the directions, probably find the confidence interval. 21 to 26 is just telling you whether you would do T or Z or can't do.